As promised, looking at linear and angular velocity. So the formula for linear velocity is v equals r times omega. So v stands for linear velocity, and that would be in any linear measurement like feet, inches, centimeters, miles, yards, and per amount of time. So then we have angular velocity, which is omega. Omega can't be any unit, it has to be radians per whatever time unit you're using. And then, of course, r is the radius, and the radius is in some linear dimension like inches, miles, yards, feet, whatever. Okay, often we are given the angular velocity instead of in omega in a revolutions per minute type of form. So to convert that, we change our revolutions per minute to radians per minute by just taking the number of revolutions per minute times 2 pi. And then we'll have that in radians per minute. Okay, so we did look at this 2018 final exam question number 16, which is kind of a little different than maybe what you'll face on your final if it's given to you in radian or revolutions per minute, which is why I went over this. However, it's still using this formula. So the radius is 30 feet long, and that's because the rope is 30 feet long. So if you have a weight and it's creating an arc, then that's the radius of the circle, is the length of the rope. It's creating an arc length swinging at an angle of 24 degrees each second. So every second it's moving an angle of 24 degrees. How far does the weight travel each second? So how far each second, that's a linear velocity. How many degrees each second, that's an angular velocity. So that's 24 degrees per second, but we need omega to be in radians. So we're going to take our 24 degrees times pi over 180 so that we change it to radians. And that reduces to 2 pi over 15 radians per second. So that's what we use for omega. Meanwhile, the radius is 30 feet. So using our v equals r omega formula, we do 30 feet times omega, r times omega, 2 pi 15ths radians per second. So the radians does not end up in our final answer. This just has to do with finding the linear distance around the circle, or the arc length in this case. So 30 divided by 15 is 2, and 2 times 2 pi is 4 pi. Put that in a calculator and round it to the nearest point 1 foot, and we get 12.6 feet per second.